Okay, here we go. We have a different method today. This method is super cool. We have a function. Now, do not draw this second part because I'm going to do something incorrect. I know that's a surprise to you that I'll do something incorrect, but I'm going to do that, okay? Suppose I take that shape and I revolve it around the y-axis. Well, everything you've been doing so far says, hey, if you're revolving around the y-axis, then let's do some rectangles that look like this, right? Yeah, exactly. And you start revolving around, and what kind of shape do you get? You get a washer. And you're super excited right now because you're on the test, and you're like, Mr. Gens said this is going to be a tough test. This is super easy. I've got a washer. I know all about washers. And so here we go. And so all of a sudden, I'm like, well, the formula for washer is pi r squared minus little r squared. And so I set it up, and I say, well, what's big R squared in this one? What's big R? F of x. So you take that guy and you square it. Boom. Minus what's little r? Oh. Yeah, it's same curve. Same curve determines the inside and the outside, right? That's problematic. You see how that does not work? Big problem. Thank goodness for mathematics. Math steps in and says, hey, we can take care of this. What? Future us, exactly. So what I'm going to do is I'm going to take that f of x and I'm going to do something different. Instead of drawing these horizontal rectangles, I'm going to draw a vertical one. And I'm going to take that vertical rectangle, and what I'm going to do is this. If I rotated this around the y-axis, can everybody see that you got kind of this oblong shape that's got this dip in the middle? Okay? And so if I wrap this rectangle around, I'll get another spot over there. But then I'll get a cylindrical shell. Now, I'm going to draw one more. Maybe I'll draw two more. And so you can start to get a picture for what this really looks like, because we're going to have a whole bunch of them. Has anybody ever seen those Christmas toys? They're wooden, and they're like little people, and they go inside of each other. So like, what? Okay, somebody say it so I can understand it. Russian dolls? Russian nesting dolls. Okay, so we got like some Russian nesting dolls going on here. Okay, so like you could do another one that would stack right outside of it. Yeah, duh. Or is so I anybody ever fired a weapon and you get a gun casing shell from that? Really, really thin on the outside, hollow on the inside, right? Same type of thing that you're getting right here. Okay, so I drew 3 of them. You don't have to draw all 3 of them. You just draw one. That's fine. The point is can you see that you're going to have a lot of these? If you wanted to, you could make them thinner and thinner and thinner so that you would eventually have an infinite number that would make up that shape. Okay? So the question is, how do we find the volume of just one of these? Oh man. Well, let's take the red one and let's take that shape and let's unravel it. Oh, okay, so if I unravel it, it's going to make like a rectangle, right? It's going to make a rectangle. Okay? It like a label of a soup can if you unravel it. Yes? So let's think about finding the volume of this label. What's the width of the red rectangle? Dx. Okay, well, that wasn't too bad. Um, let's figure out the height. What is the height? F of x. Ooh, how do we find the length of a soup can label? It's the same as the circumference of the soup can label, right? So how do you find circumference? So the volume of this guy is 2 pi r f of x dx. Now, your last question is, what is the r value, Mr. Gens? Well, it changes depending on the problem, but in this situation, I'm going to just show you right here. Suppose that we were integrating from a to b. Wouldn't that just be some x value sitting in the middle? And if we start at 0, what's the distance from 0 to x? X. So the radius many times just ends up being x. 2 pi x f of x dx. It's just some x value that sits between 0 and b. So therefore, the volume of cylindrical shells, integral 2 pi on the front, x f of x dx a b. Looks super complicated, and a lot of people fight it and say, I would rather do washers if I can. Sometimes you can't do washers. But in this situation, it actually is a lot easier to use cylindrical shells. Let's look at this first example. It says find the volume of the area bounded by 2x squared minus x cubed and y equals 0 revolved around the y-axis. First of all, what the heck does that look like? If you factor out an x squared, you get 2 minus x. So what is 2x squared minus x cubed? What shape does that make? Somebody draw me a little squiggle thing. What do I get? Start up and finish down, start down, finish up. Starts up and finishes down, right? Looks like it's got a double root at 0. So this graph, I'm just going to draw a really quick sketch of it. This graph looks like this, where that's 2 and that's 0. Everybody see it? So we're bounded by that, and y equals 0, which is the x-axis. So we've got, this is our region right there, and we're going to revolve it around the y-axis. So I'm going to draw that shape. Revolve it around. I really want to do a washer, but why can't I do the washer? Yeah, if you draw the rectangle, you see that the inside is the same as the outside, right? big problem. So we resort to a different option. Stop throwing stuff around. Way to stay hydrated. Draw my other rectangle. And I rotate that rectangle around. I get a beautiful cylindrical shell. Do you like that shell? Cole does. Thanks, Cole. Appreciate your optimism. Yeah, he did. He nodded. I'm going to unravel this guy. Somebody want to tell me the width of that unraveled rectangle? dx. Love it. What's the height? Yeah, 2x squared minus x cubed. And then, what is the length? 2 pi times the radius. Now, the radius is going to be the distance from 0 to this x value. And that's 2, right? So x could be any value between 0 and 2. Agreed? So what's the distance between x and 0? X. So 2 pi x is your length. X is going to be a value at which we draw the height. X could be anything between 0 and 2. What is the distance between x and 0? It is just x. So we multiply these together. 2 pi times x times 2x squared minus x cubed dx. Slap in an integral. So we do an infinite number. What are our bounds? 0 to 2. So 2 pi integral 0 to 2. I got 2 times 2x squared is 2x cubed minus x to the 4th dx. Oh, man. If only I knew how to do integrals. Wait, I learned how to do integrals in Chapter 5. Fundamental Theorem of Calculus, Part 2. What's the antiderivative of 2x cubed? X to the 4th over 2. What is the antiderivative of x to the 4th? Remember when those used to be our assignments? So like, we're going to find antiderivatives. How smart we've gotten since then. It's just like how I'm feeling that day. It's kind of like, you know, am I feeling blue shirt, yellow shirt, green shirt? I don't think it matters. All right, we plug in 2, and we get 2 to the 4th is 16 over 2, 8. I'm going to raise 40 over 5. I anticipate that 5 coming up. Darn 5. I got 2 to the 5th, 32 over 5. What's 40 over 5 minus 32 over 5? Times 2 pi. Yes, 16 pi over 5. That a boy. Not even that hard. Yeah. Interested in hearing that. Be a good project. I bet you get an A on it. Then give me $5. Okay, find the volume of the area bounded by y equals x minus x squared and y equals 0 revolved around x equals dos. Yes, some people do not know Spanish. Very good, D. Wyland. Okay, I don't know if we're ready for this. This is difficult. You want to give up now? Okay, now you failed. You were supposed to say, no, Mr. Gens, we're ready to try harder. I agree. You guys are ready to graduate. You got less than 8 weeks left. It's no big deal. We're almost out. All right. So I've got x minus x squared. Somebody tell me what the heck does it even look like? Upside down parabola goes through. Everybody agree it goes through 1 and 0? Where am I revolving it around? X equals 2. Ooh, that's a little bit different, huh? Switch it up. I like the way you think, Rebecca. So that means it's going to go over there, right? And immediately you say to yourself, well, I know how to do this. We're going to draw me some washers. Why? Inside will be the same as the outside. Doesn't work. Forget it. Okay. Cylindrical shells. Well, thank goodness somebody came up with these cool cylindrical shells. These Russian stacking dolls. That's whatever. You guys made it up. Yeah. Do a report on it then. Tamara, don't disagree with me. You'll make me angry. Some days you hurt my feelings. Okay. What do you think about that? Okay. All right. Riley says dumb. Thank you for your input, Riley. No, I don't know what you don't understand. Share with me what you don't understand, D. Wiley. Like the red thing? It's 3D. That's the width. It's got depth to it. Thickness. dx. You good with dx? Okay. What's the height? That's super easy. You guys are like, hey, there's no big deal, Mr. Gans. Like you made a big deal out of nothing. Now we got 2 pi r. Ooh, and that's where we're wrong. This is x, and this is 2. Now, be very careful. Let me walk you through this. Everybody agree that this spot is 0 and this spot is 1? Suppose you're at 1. What's the distance from 1 to 2? How did you get that? You did 2 minus 1, right? If you were at 0, what's the radius? 2. You did 2 minus 0, right? So say, for example, you were at 1/2. What would be the length? What would be the radius? 1.5. You do 2 minus a half, right? So what's the radius? 2 minus x. Right minus left. See it? Very good. Just for the record, I felt a little bit off yesterday not seeing you guys. I don't know if you guys missed me, but I did miss you. Don't even remember. 2 pi times, what are the bounds? 0 to 1, my original area. 0 to 1. And I have 2 minus x times x minus x squared, dx. We good? All right, let's FOIL that out. 2 pi, integral 0 to 1. Sorry to all you who are offended by the term FOIL. Some teachers don't like the word FOIL. Yeah, get over it. They think it's just, they think it doesn't properly explain what you're doing. Okay, so we got negative x squared, and then I got negative 2x squared. I got negative 3x squared plus x cubed dx. Antiderivative of 2x x squared. Antiderivative of 3x squared. Oh, look at that. Aren't I making this a nice problem? Antiderivative of x cubed. Ah, darn, x to the 4th over 4. Yeah, it's just 1 and 0. Look at that. This, again, is helping us out every day. What a good guy. 2 pi times 1 minus 1. Yeah, baby. Times 1/4. Pi over 2. 90 degrees. Yes. Amen. That's your answer, 90 degrees. Some people ran with that hook, line, and sinker. Kenzie, did I get you? No, you're like, I get the math joke right away, right? I mean, you're converting degrees to radians back and forth. Pi over 2 same as 90 degrees. But we're not talking about an angle measurement here, so I don't know. It's kind of fun to think about. Every year we get to that spot, it's always a good laugh by everybody. Are you ready for the last one? The last one of this unit. I had none. Rowan showed up to me, or showed up today. Rowan showed up today to class to see me. I feel like she's saying, you know what, Mr. Gensler, I'm going to make your class priority. And she even came with news about vaping and tobacco products. Rowan is our expert on vaping products. Dear YouTube. Oh, wow. All right, here we go. Find the area bounded by y equals x squared and y equals x revolved around the x-axis. Oh, boy. Y equals x squared. Parabola. Y equals x. I want to draw the other side because I know that it's not going to create a bounded area. That this is the only part that creates the bounded areas I think about in my brain. Okay, I'll draw the whole thing. See how this other side is not bounded together? But this is. So I just drew the side that was bounded. There we go. All right. Anybody know the points of intersection? 0 or 1, 0, or no, 0, 0, right? And then this would be 1, 1. Good. Revolved around the x-axis. So when I revolve it around the x-axis, I get that, right? Now, the fact is that you can do washers in this scenario, but we're not going to because we're better than that. We're going to use cylindrical shells to show you that you have options. You could do both and check your answer. Everybody see my cylindrical shell? Yes, it is kind of off. Thank you for pointing out my mistakes. It's okay. All right, I'm going to unravel it. Oh, yeah, I did mess that up, didn't I? Yeah, I did. Oh, well. Okay, sorry about that. All right, I'll redraw it. I'm sorry. I'm not perfect. Right. Okay, is that better? So the curve should be on the inside. I had it on the outside before. I didn't flip it correctly. Yeah. We're just gonna go with it, okay? Nope. Okay, so I unravel it, I get that. What's the thickness of the rectangle? dy. Oh. Oh my goodness. Got dy. What's gonna be this amount right here? Okay, so you see the x squared minus x, but it has to be in terms of y, doesn't it? So this one is just x equals y, so that's no big deal, right? And then this one is x equals the root of y, right? So all of a sudden it's the root of y minus y. A for the day, who could come up with the radius? Be y, right? So what we have to do is you have to take your right minus your left. Right minus the left. The right function is this one. The left function is this one. Has to be in terms of y. So root of y minus y. My bounds are going to be from 0 to 1. Everybody can see that I'm 0 to 1, right? So then the question is, what is our radius? Well, the radius is some value here. This is a y value, not an x value. What's the distance from y to 0? So therefore, this is 2 pi y. Good job. We're almost done. You guys are a very smart class. Let's multiply this out. I get 2 pi y times, I'm going to raise y to the 1/2 minus y dy. That represents the volume of one of those unraveled rectangles. Multiply it out, and I have 2 pi y to the 3/2 minus y squared dy. That's the area of one, or the volume of one. How many do you want? How do I do that? Slam on that integral. Well, if you're going to try to make fun of me, I'm going to make fun of you. All right? And I've got a lot more practice at making fun of people. I've been doing it for 17 years. And you're pretty ugly. All right, here we go. All right, 2 pi. What's the antiderivative of y to the 3/2? Wow, man, you guys are aggressive. 2y to the 5/2 over 5 minus y to the third over 3. Evaluated 1 and 0. Thank you, Mr. Gans, for giving us 1 and 0. Well, you're welcome. Plug in 1, I get 2 pi times what? 2 over 5 minus 1 over 3. Common denominators, 2 pi times, let's see, multiply by 3, I got 6/15 minus 5/15. So 2 pi for 15. 24 degrees. I was waiting for it. Nice work. Give yourself a round of applause. Yeah.